I'll use 4. You're welcome.
Ready for the A-switch test?
No, I'm not ready for it.
Yes.
Thank you. Stop it.
Don't say it.
Stop it.
You're not saying it right.
I know. That's what I'm saying. Stop
I
it.
said your name's right, as far as I know.
I don't even know how to say it.
The 2 jars are the same today?
It's double.
That's exactly.
You said double.
Yeah.
Stop it. Stop it.
When you lose the race, did you get brownie points?
Well, I'm not going to lose it, so then no. Yep.
Can we get brownie points?
No.
So if you win, you get brownie points?
No.
If you lose, you'll get money.
If it's a tie, you get brownie points?
No, it's just going to be a tie.
If you lose really bad, you get
Alright.
Is this it? Really? Oh, wow. Okay.
So, today, we're going to be doing 3.2 from the book. We're going to talk about differentiability.
Oh, yeah.
Basically, if something is differentiable or not. Can you take the derivative of something?
I knew it was a lot.
How's it back? Okay, so there are 4 cases when something is not differentiable. There are 4 cases when you cannot take the derivative of something. These are the 4 cases. When there's a corner, when there's a cusp, which is kind of like a corner, but it rounds out like that, but it's still kind of a corner. Where there's a vertical tangent, because we can't have the slope be infinity.
That's right.
I know.
There's no straight up.
Exactly.
I never noticed that.
Because there's slope, that would make it, something over 0. Can't have anything over 0. So you can't take the derivative when there's a vertical tangent, when there's a vertical slope. And when it's not continuous, when there's a step function.
A vertical tangent.
Yep.
What does that mean?
That means you go over 0, right?
Uh-huh.
You can't have 0 in the denominator.
Oh, okay. Good.
So these are the 4 cases where you cannot take the derivative at specific points. Or where you can't take the derivative of the function. Because it has one of these 4 things in it. So if it's an absolute value, if it has a corner, if it's a cusp, if it has a corner, if it has a vertical tangent, or if it's not continuous, if it has, a jump, you cannot take the derivative of these functions.
Where can you find a cusp?
I'm thinking it's kind of like positive, negative square root or something.
Oh.
Yeah, we don't really see these graphs that often. But that is one of the cases. Okay, so the derivative of something has to be continuous. But it doesn't work the other way around. Just because it's continuous doesn't mean it's differentiable. Because these 3 are continuous. You can trace the graph without lifting your pencil, which makes it continuous, but you can't take the derivative at specific points.
What, so if it's differentiable, it's always continuous. If it's continuous, it's not always differentiable.
Exactly. So it's only one way. If it's differentiable, it's always continuous. But just because it's continuous does not mean it's always differentiable. Okay, any questions with these 4 graphs or situations? Anyone still copying this down? Yeah, okay. Alright, so you're going to find the point where f is not differentiable. So you can do this however you want. You can graph it by hand, you try to solve for something, you graph it in a graphing calculator. Just give me a point that makes this graph not differentiable. But don't yell it out. Find a point that is not differentiable. And you should be able to graph this without a graphing calculator. You got it? Good. Yeah.
Is the option higher than this one?
You got it wrong?
It's not differentiable.
I'll have a race to do whatever I want.
Okay, anyone still working on this? Alright, so hopefully you were able to graph this by hand. Okay, first of all, what type of graph is this? Absolute value. So it's going to look like a V. That minus 2, what does that do?
Right, left, right 2.
Which way?
Right.
Right 2. Right? If it's kind of like in parentheses, or if it deals with the x directly, it's a horizontal shift opposite of what it looks like. So that's a right 2, and then the plus 3 is up 3. So right 2, up 3. So there's your vertex.
And it's not differentiable.
So where is it not differentiable? At 2, 3. At the vertex.
Yay.
Okay, any questions there? Okay, make sense? Okay, local linearity. Differentiability implies local linearity.
What is this language?
Huh?
What is this language?
English.
Sounds weird.
I don't know what else to tell you. So, if it is differentiable, then it is locally linear. And I'm going to explain what that means in a little bit. If it's differentiable, then it is locally linear. Differentiability implies local linearity. Yeah?
So for the other example, it's pretty much we'll like graph the given function here.
And then you see where there's a corner, or where there's a jump, or where there's a vertical tangent. So you graph it if it has one of those 4 cases that we talked about earlier, that is not differentiable at those points. Yeah, someone else had a question back there? Alright, anyone wants to comment down, because I'm going to switch the screens. Okay. So basically, local linearity is where if you zoom in at a specific point, it should look straight. If You zoom in at a specific point, it should look straight. You continue zooming in, it's going to look straight eventually. So locally, it will look linear. Okay, so here we go. So take out your graphic calculator. If you don't have one with you, share it with the person next to you. Alright, we're going to graph a function. Let's graph an easy function that we know is differentiable. Give me a function that's differentiable, somebody.
X squared.
Okay, x squared. Okay, everyone agree that we can take the derivative of that?
Yeah.
Okay, let's look at the graph first. Do we see any jumps, corners, vertical tangents? No. So this graph should be differentiable, right? Okay, everyone okay with that? Okay, so now we're going to zoom in at a point. Let's zoom in at 1, 1. So the way we zoom in at 1, 1, well, there's a couple ways. Someone give me one way you would do this. Okay, press zoom. I think if you want to zoom in somewhere, the zoom button is probably a good place to start. Okay, now what? Okay, let's zoom in. So 2. And then you can tell it where to zoom in. So if we're trying to zoom in at 1, 1, what's a good place to zoom in?
1, 1.
1, 1, good. So that's close enough. So you move the cursor over there. Everyone okay with that? Hit enter. Does that look straight? Not really, right? I mean, it looks like it's getting there, but not really, not good enough. So let's zoom in some more. What do you want to do? Okay, let's type or click on zoom. Number 2 for zoom in. Is that a good spot? The cursor's right there. Okay, so then hit enter. Does that look straight? No? Okay, alright, whatever. Let's zoom in again then. Zoom. 2. Does that look straight?
Yeah.
A little bit.
Okay, then you're just a jerk. Yeah,
You're just a jerk.
it looks pretty straight to me. So that's what it is. Locally linear. Means at a specific point, like if it's super, super close, it's straight. And between intervals 1.01 and 1.02, I mean, that's straight. Right? That's basically straight. It's locally straight, locally linear. So, if you can take the derivative of something, that means at any point on the graph, we can zoom in a bunch of times, and it will look straight.
At some points?
Yeah. Any questions? So, let's look at something that is not differentiable. Let's go to zoom standard real quick. Let's go back. Let's change the function. Give me something that is not differentiable.
Absolute value of x.
Okay, good. Absolute value of x. Now, the only problem with that is where it's not differentiable is right along the x and y axis. So it might fog up the vision. So let's move it over a little bit. So to type in absolute value, hit math.
X minus 2.
Go to number. That means absolute value. Let's go x. If I want to move it to the right 2, what do I type?
Minus.
Okay, good. Minus 2. Let's close the parentheses. Let's say I want to move it up 2. Plus 2. Okay, that is not differentiable, right?
No. Absolutely. What?
X minus 2 plus 2. Okay, everyone agree with that? Yeah. Oh. So the absolute value, so you hit math, go over to numbers, and then absolute value. X minus 2, close parentheses, plus 2. And hit graph. So you should get that? Okay. So let's zoom in. And let's go over to 2, 2. Hit enter. Okay, does that look linear?
No.
No. So zoom in again. Does that look linear? No, let's move over a little bit and zoom in one more time.
You can just keep on pressing enter.
Okay, let's press enter. Bam. Does that look linear?
Nope.
No, eventually, as we keep zooming in at that point, will it look linear? No, because there's always going to be a corner there, right? That's why this function is not differentiable. Any questions? Does that make sense? So, you can keep trying, but it's going to take a while. Like infinity. You will never find it. Okay, so if you're ever not sure if you're just looking at a graph, you can't remember if it's differentiable or not, think about it this way. If you zoom in at any point on the graph, will you get a straight line? Right, and that straight line is actually going to the tangent line. And that straight line is actually going to the tangent line. Okay. Compute the numerical derivative of x cubed at x equals 2 using a graphing calculator. Okay. So this is what you're going to do. Okay, I guess you're going to copy this down first, so I'll wait. Yeah.
Did you already have your race?
No, it's after school.
Oh, after school. Good luck.
Thanks. No, I don't know how it's gonna react to my body. I don't want to go crazy fast in the first minute, and then super slow after that. Yeah.
Are you still racing with this out?
Huh?
Are you still racing with this out?
Yeah. Well, technically it's a race, I guess, but it's really gonna be whatever the word is of me whooping on her. Yeah.
Mr. Chang, you have to learn or you're going to owe all of us on your ticket.
What? I never agreed to that.
Well, I mean, you would be wrong about
Yeah, you're wrong.
winning the race.
I mean, Jack, since you're so confident, I think you should do that. Since you're so confident about being this out.
He's been running every day.
I know. I'm actually not that confident. You
I
lie.
don't know.
You're a guy.
People are getting in my head.
That ego stuff.
What?
I was just talking about how you cheat.
Oh, yeah. So this is my plan. I'm gonna start off really slow, right? Like everyone get in front of me, hop in my car, drive around, park towards the end, and then get out, and then wait for a couple people to pass me because they gotta make it realistic, right?
Yeah.
And then probably throw some water in my face, and then once I see Miss Zhao, just start running. That's my game plan. So
Can't fit.
yeah, so I
I
can't
tried to
fail.
wait for you.
Okay, everyone copy this down? Okay, so I'm going to show you guys how to take the derivative on your graphing calculator. Now, that doesn't mean, though, on a test, you're going to be able to do it on your calculator every time. Because it doesn't work sometimes. I'm going to show you when it doesn't. So compute the numerical derivative. So we want to take the derivative of x cubed at x equals 0. So we don't need to use that function, the formula anymore. We don't need to use the definition anymore. We can use a graphing calculator. So you can hit math. Alright, so let's clear this. Hit math. Go to n derivative.
It's number 8.
There we go. Number 8. Hit enter. Enter equation. X cubed. Close parentheses. And value for x. I guess 3. That's not what it showed up on the other calculator. Hold on.
I'm gonna grab
Wait,
it.
what is this?
You don't have it on the white flag.
Yeah, that's not. Hold on. Why isn't it working on this one?
Because you're not putting y equals.
Y equals?
You're just having like a regular equation.
So am I supposed to do in the y equals part?
Yeah.
No, I think so.
Well, I'm not trying to graph it.
You're just trying to find the derivative.
Yeah. Okay. Yeah, it's not working on mine. It's working on my other one. Okay, so yours should look something like this.
It looks like a fraction.
Yeah, it should look like a fraction.
Oh, okay.
That's great. So you go to math, and derivative. So, okay, so this is what it's going to look like. this is what it should look like. I don't know what the other thing is doing. So it should look like d over d, and then you have a box here, parentheses, a box here, a line and a box here that you can't enter anything into, equals, and then a box here. So these are dotted. Okay, everyone getting this?
Oh, mine's not that high tech.
Okay, then I don't know. I gotta look at yours later. Okay, what you want to do is enter x in here, because that's what you're taking the derivative of. You're taking the derivative of a function in respect to x. This is where you type in the function, so x cubed. X cubed. And then the number is 2, so 2 is where you plug in there. And then once you plug x in here, this should automatically turn into an x.
Yeah. Yeah.
Okay. And if you hit enter,
How do you do this?
yeah, so you get 12.00001 or something like that. The derivative is 12.
Yeah, it might be more.
This looks like the one over there.
Yeah.
I don't know. I have to look at it. Come on, it's a 3.
5.
It's a 3. Okay. Alright, any questions there? And that's how you take the derivative on your calculator. Now it says 0.00001, but that's because, remember, we're dividing by h, right? So it's just taking a number really close to it. So you can kind of ignore it and then just assume it's 12. Alright, any questions there? I know some of your calculators may not work. I don't know why. I have to look at it. Alright, here's example 2. We're going to do the same thing. So here's math, and deriv, x, absolute value, so hit math again, put a number, absolute value of x, as x equals 0. Hit enter, you get 0. So you should write x in there, absolute value of x, and 0. Okay, any questions as to how to type this in? And then when you press enter,
Mine says air.
Mine does the end derivative thing.
okay, does it look like this?
No.
Then I can't help you right now.
It just says end derivative.
Okay, then I will look at it later. Okay. Any questions with the people that got this?
Wait, so you plug in X and then absolute value.
Yes. Yes.
It comes out.
Alright, if you hit enter, what do you guys get? 0. Well, you should get equal 0. What?
I got one.
Okay, it doesn't really matter what you get, because can we take the derivative of absolute value? No. The graph looks like this. There's a corner. So your calculator will tell you that the derivative is at 0, or is 0. But that's not right. It's not true. It's not correct because there is no derivative
Are you telling
at x equals 0.
us not to trust our calculators?
So I'm telling you that your calculator is just a tool. Right? It's not your mind. So you got to be able to know this stuff still. So you can use your calculator, you can plug functions in, you can plug numbers in and get something, but you really need to be able to think about what you're plugging in, what the calculator is telling you. Because this is not true. Okay, that's not correct. And you can bet that there's going to be a question like this on the test, for those of you that just plug stuff into your calculator. Alright, any questions? Okay, it's just like sometimes, when you plug in negatives and you're dealing with negatives, the answer that they gave you isn't the correct sign. It's because you're entering it incorrectly, but you know what's positive and what's negative. Like some of you guys, when you type in -2 squared, it'll tell you it's -4. Right? Obviously, it's not -4. So you got to be able to think critically about what your calculator is telling you. All right, any questions? All right, theorem 1. Okay, so there's a couple theorems that you need to know. You don't need to memorize what theorem 1 is saying, but you need to understand it. And then it's going to start coming to you naturally. Like, I'm not gonna ask you what theorem 1 is, and then you tell me. But you should know what the actual theorem is. Like if I ask you, if it's differentiable, does that mean it's continuous? What's the answer?
Yes.
Yeah. Because that's theorem 1. Differentiability implies continuity. If it's differentiable, then it is continuous. If you can take the derivative of a function, then that function is continuous. If f has a derivative at x equals a, then f is continuous at x equals a. Draw a graph, an example. Alright, so I'm going to draw a graph as an example. Bam. Is that graph differentiable? Yes, right? It's continuous. There are no corners, no jumps, no vertical tangents. This graph is good. It's a solid graph. Yeah.
What do you mean that f is continuous? Oh, function.
So here's some number. If f, so this is f, the graph, has a derivative at x equals a. So right there, can you take the derivative at that point? Yes. You can take the derivative at that point. That means at that point it is also continuous. A lot of these theorems you already know as you're learning this stuff. But I'm just kind of giving you the theorem so you can see it one more time. No one is shocked by this theorem, right? Hopefully. No one's blown away. It doesn't change anyone's life, right? So, if it's differentiable, it is continuous.
Oh no.
And if it's differentiable at a point, then that point is also continuous. That's all that means. Alright, any questions? Make sense? Okay, so all you're going to be doing for your homework is telling me if something is differentiable or not, and then at what point it is or at what point it is not. There's your assignment. You got a couple of review problems. And then you're going to be plugging this into your calculator to give me the derivative. Someone give me a calculator that wasn't working. Is it yours?
Yeah.
Let me see.
No, yeah, it is. It is.
And
Along that.
derivative of x.
I'm really enjoying this, Jordan.
This is on your
Too bad you can't. Alright, come here, everybody. Anybody want some animal crackers?
Anyone still copying this down?
Yeah.
You have an 89. I don't know what you want me to do.
What about me? How many drink?
Let me look it up online. I can. But I'm looking at the 89 real quick. It's 83. How to take
Huh? No.
Oh my god, look.
Piece of chocolate.
Look at my money. I know, right? Like, I know so.
Alright, so let's try this. Paste n derivative function. Okay, so math derivative.
Let's score 83.
First arguments. Yeah, 83 and 84. So let's try x squared.
I will practice if I ask.
X squared.
I hope you know I'm a grammar not student. This is not like where I would put.
Comma x. Okay, that's what I tried earlier. Oh, okay, I forgot to close the parentheses.
Posterity. Do that to posterity.
Hey, I didn't write that.
Remember what Miss A
I didn't write that.
Don't throw in
Bam. Alright, I got it.
fancy words in there just for that.
So this is what you gotta do. So you still go to math, hit 8 for the derivative to get n deriv or whatever it is. Right, open parentheses for you. Let's say you're taking the derivative of x squared when x is equal to 3. You're going to type in the function x squared. You hit a comma. What are you taking the derivative of? We're taking the derivative of x. You hit a comma. As x equals what number? 3. And this should give you 6.
So that's wait.
Wow.
6 is derivative of.
So the derivative of x squared
Yeah.
in respect to x of 3 is equal to 6.
Yes.
Oh, I think I did it too. That was x cubed the last time. So this same thing as this right here. D x x squared. Yeah.
I don't know how much money I need.
You have an 89. Did you hit plug that in 3? Well, 2x is the function that has to take derivative, so maybe you just gotta plug in 3 yourself. So this is the same thing as this.
How much is
The x squared is there, the x is there, and the 3 is there.